Hello. Thank you all for joining us today for Caringo's Tech Tuesday webinar. This session's topic is Object Storage Capacity Planning for 2020 and beyond. I'm Sarah Cook, Director of Marketing at Caringo. For today's webinar, I'll be your host, and our subject matter expert is John Bell, Senior Consultant at Caringo. John will be available to answer your questions throughout the webinar and at the end of today's presentation. In addition, we have several resources available via the Attachments and Links tab on your view screen. If you have any questions after the webinar, you can always reach us by emailing us at info@caringo.com. So I joined the Caringo team in 2015 and I'm based in our Austin, Texas office, which is our headquarters. And one of the biggest draws that I saw coming to Caringo was the opportunity to learn about object storage directly from Caringo engineers. So without further ado, I'll let our subject matter expert and the man who always has the answers to my questions introduce himself. So John, why don't you take it away?
Thank you, Sarah. It's good to be the man with all the answers.
Isn't it?
It is. So again, I'm John Bell. I've been with Caringo for 8 years now. And I'm a senior consultant based in Austin, Texas, along with Sarah. And I specialize in the design, implementation, and management of object storage. And I've had the opportunity over the years to work with many of our largest customers to transform their storage infrastructure with highly efficient and cost-effective object storage solutions.
Great. So I'll share a little bit about the history of Caringo before John starts getting into the nuts and bolts of capacity planning. But Caringo was founded in 2005 to change the economics of storage by designing software from the ground up to solve issues associated with relentless data growth, which we all know have only skyrocketed over the past dozen or so years. Caringo's flagship product Swarm decouples data from applications and hardware, providing a foundation for continued data access and analysis that constantly evolves while guaranteeing data integrity. Today, Caringo's software-defined object storage solutions are used to preserve and provide access to rapidly scaling data sets across many industries by organizations such as NEP, Netherlands, Argonne National Labs, the UK Science and Technology Facilities Council Scientific Computer Department, and I challenge you to say that 3 times really quickly, Texas Tech University, a university here in Texas that we are very proud of, the U.S. Department of Defense, the Brazilian Federal Court System, British Telecom, and literally hundreds more worldwide. So I'm going to let John take the wheel and walk you through our agenda for today and start giving you information. If you have any questions as we go through the presentation, feel free to just type them into the chat box and we will try and address those during the presentation.
Very good. Thank you, Sarah. Well, everyone, let's go through a quick overview of what we plan to cover today. We'll start off with a top-level overview of what I consider to be the basics for storage capacity drivers, specifically for object storage solutions. And then as we go through it, we'll dive down into the specifics of various components, not only the core components of Swarm, but also the additional product offerings such as Swarm NFS, Caringo File Fly, and so on. We'll dive into elasticsearch sizing, which is a fairly important piece involved in all of this. Sizing your Swarm gateway farms for access into storage, including some considerations around the API protocol personalities such as S3. Planning capacity for deploying Swarm NFS, the same for Caringo File Fly, and then we'll also show you some top-level hardware reference deployments that we make available that are part of our new software appliance, our offerings that we're going to be bringing to market. So let's dive into the basics. When someone comes to me and they ask me, I want to size our storage for an initial deployment, and then of course I want to be able to monitor it over time and make sure that I can do capacity planning, based on the trends that I see and extrapolate from them. And there are typically 4 areas that we take into account when we go through that exercise, and the 4 things that drive this. The first and foremost is going to be your anticipated or measured count of objects, object count, associated with the average size of the objects that are going to be stored in the cluster. Those have drivers. Those drive various aspects of the architecture and your hardware choices. It's very important to have a handle on those 2 items if you want to perform this exercise correctly and be accurate. The next and closely associated with that is the protection scheme choice, whether you're doing a multiple number of copies, for a better way to describe it, with replication, whether you're splitting things up into data and parity segments, with erasure coding and the ratios that are associated with that for logical and actual footprint and the associated segment counts and so on. There are also things you need to take into account when you're determining what level of data or cluster availability you want to design into the solution. What kind of failure modes you are comfortable with. What your tolerance is for having something fail while the storage system is running, while still being able to present data to the end users. And there are some other minor considerations that fall out after that. Really, those first 3 blocks that are specifically outlined are the primary drivers for planning, storage capacity, storage service, and how performance and whatnot scales over time. So let's dive into that first one, which is the object count and average object size. I call these the primary drivers for object storage capacity planning. If you don't really have a handle on this, you're just kind of guessing, whether it's a greenfield deployment or whether you've been in place for a while and have been putting data in the system. If you can't track the trends that are going on with object count and object size, you're going to have a rough time with capacity planning. The reasons for that are object count is going to drive the memory requirements for the storage cluster. And the reason for that is, in the case of our solution, is that we index all the streams that exist on a volume, like a hard drive, for example. And we put all that in main memory. So the more objects you have, the more main memory you need to be able to populate that volume index. And that's why memory is so important there and why it's driven by object count. The average object size multiplied with object count is going to provide you with a logical storage footprint result. And that kind of gives you a feel for, in the case of a new deployment, what you're initially going to ingest. And then if you know you're going to be bringing in so many objects over a given period of time at a given size, it allows you to extrapolate from that and see, how much more you need to expand the storage cluster, going into the future, like say over a quarterly or semi-annual or annual time frame. The average object size is also going to provide you guidance on the next key driver, which is protection scheme. And make you decide whether or not you want to go with copies or whether you want to erasure code that data. We'll dive into that in a little bit, but that kind of falls into that. The two tend to be fairly well coupled. Okay, so the reason protection scheme choice matters is not only is it going to drive storage cluster memory requirements, it's also going to drive the amount of raw hard drive space you need to store the data in the system. One thing to bear in mind from a memory perspective is that erasure coding memory needs are going to be greater than replication memory needs. And the reason for that is the mechanics behind how erasure coding works. And we have an example of that in the diagram there. In the case of replication for a file to protect it, let's say you're protecting it with 3 replicas. Then the result of that from a memory footprint perspective would be you would have 3 index slots that are used in main memory to keep track of those objects in the cluster. In the case of erasure coding, storing the same thing, you're splitting it up into segments, a combination of data and parity streams. So in the case of a 6.2 encoding, you have 6 data streams and 2 parity streams. Now your storage footprint is much different as a result. Instead of it being 200% overhead for storing that object, it's going to be 33%. for storing that object in the case of 6.2 encoding. But in main memory, you're going to have many more index slots that need to be used to keep track of all of those segments, because each of those segments is treated as something that needs to be tracked in main memory as it exists on the volume. So memory utilization goes up while your disk footprint needs go down. So that's a design trade-off that you have to make when you're initially rolling this out and you're making choices on what kind of protection scheme you're going to need. Erasure coding is also going to have an impact on CPU performance, and it may drive the need to purchase faster CPUs as a result. And primarily that comes into play when you are writing erasure coded objects, because you have to calculate and create the parity streams that are associated with the data that you wrote into the system, and that has an impact on your CPU needs. As we note here, required volume footprint is going to be derived from a combination of your object count, your average object size, and your protection scheme overhead. And again, it's just an interplay of which path you want to go. Fortunately, in the case of Swarm, we allow for multiple protection schemes to exist at the same time within the same cluster, without any kind of special reconfiguration around rings or anything like that. We just allow it to happen. And really all we're looking for is a threshold that the operator has set for a cutoff in logical object size as to whether or not that data will be stored using replication or whether it will be stored using a erasure-coded scheme.
That's a great explanation, John. I feel like I now understand it far better than I have before.
Oh, great. Thank you. Yeah, if we go back to this, it can be a little bit tricky to get your head around. The key takeaway from here is that when you're sizing hardware for storing data, just be aware that erasure coding saves you disk space at the cost of increased memory utilization. And this is something that can actually be quantified. We're going to demonstrate this in the slide right here. Capacity drivers, let's revisit the impact on memory. What we have here is a chart, and this is actually pulled straight from our documentation, so this is fully documented as to how this works. And it's a chart of RAM per storage node for the following object types and how you plan to store them. When you start off booting a Swarm node, it's going to have a given number of RAM index slots for keeping track of what's on the volumes that's been assigned to that storage node. And depending on the amount of memory, gigabytes of memory that you have in the server, for 16 gig, it ranges from 268 million slots all the way up to 128 gig, which is 2.146 million index slots. That's just the raw available index slots available. And when you dive into the type of objects that you're storing and the type of protection schemes you're going to use, that's going to have an impact on the actual number of files, the logical files that you'll be capable of storing within the storage cluster. Long story short, you can see here demonstrated 5.2 erasure coding, of course, is going to have a cost in memory where with the same amount of memory, you can only store 26 million files using 5.2 erasure coding. Whereas if you were doing, in this case, we're assuming aliases with reps equals two reps in the system. For immutable objects, you can store, it's 1 for 1, 268 million. For mutables with aliases, it's 134 because it's a 2-to-1 ratio, and so on. And the key takeaway from all of this is that your expectation should be that Swarm's memory utilization is going to scale linearly, regardless of the type of object that you're storing and regardless of the protection scheme that you use. There's no surprises here with nonlinear curves, as it were. It's all just straight linear growth when it comes to memory.
That's great, and it actually gets more efficient as it gets bigger, correct?
In the case of erasure coding, yeah, as the cluster gets larger and objects gets larger, you're going to get much more efficiency out of using erasure coding for large objects in a large cluster. It's a true scale up, scale out architecture is what I would take away from that, Sarah.
Okay,
So we've talked about planning for things like, overhead for disk footprint. We've talked about memory footprint. We've talked about scale up, scale out, and a relative linear fashion as an expectation for how that would work. Let's talk about when things go wrong. Planning for availability. Swarm has the capability to basically heal itself if an error occurs within the cluster. If a couple of volumes go down, or hard drives as the case may be, if a server in the cluster goes down, Swarm is going to detect that event, and it's going to do what's necessary to true everything up in the cluster to make sure that your data is fully protected and fully available. And in order for those repair operations to take place, you have to account for a little bit extra available resource to be in the cluster so that you can account for a certain failure type. You're going to need extra drive capacity to accommodate volume or server failure. And what you're going to design for, you're typically going to kind of account for multiple volume or multiple server failure scenarios. And a good rule of thumb for this, and one that we actually display in the UIs, is that when a cluster's use capacity reaches 80%, it's a good rule of thumb to consider expanding the cluster at that point, because that means that if you have some volumes die, or if you have a server or two die, you're going to have room in the cluster to perform necessary repairs and true everything up until those drives or those servers are brought back online again. Your availability requirements, they could range from the very simple to the highly complex. And ultimately what happens is that those decisions and those requirements feed back into your protection scheme of choice. So there's a little bit of a feedback loop here when you start planning for availability, and it's something that you'll want to account for as part of the overall planning process. So what are some other considerations you need to bear in mind when sizing for an initial install, and then trying to anticipate how much more you need to add to the cluster over a given period of time? There are certain features that you can enable within Swarm, which may require more resources to properly support them. Some examples of that include items such as our overlay index. And that's used typically in what we would consider to be large, 32 node or server or greater clusters. The purpose of the overlay index is to basically facilitate speed in locating objects as part of the bidding process for determining who's going to service the request in a cluster. And as a result, things get found faster. It drops the level of network traffic that's associated with that as a result. So it's a good feature to have, especially in large clusters, but it's going to need more memory in order for it to work. The typical rule of thumb for that is that you want to assume an additional 25% of total cluster memory added, and spread across the systems to support the overlay index feature. And when it comes, and that's just one example. When it comes to any kind of feature that you're considering using, whether it be for the initial install or one that you decide, after putting data in the system, oh, I really need to take advantage of this feature, you're going to want to account for that resource impact before enabling it in your cluster. And if you're not entirely sure what the resource impact would be, it's always a good idea, of course, to contact Caringo support, and we can help you out with that exercise. And we also do a very good job of documenting these rules of thumb for certain features in our documentation. Some things have very little impact. Some things like the overlay index have a very large impact. So it's always good to bear that in mind when you're turning things on and off.
Well, I was going to ask, if somebody needs help with this is something that we can go in and help them with, is figuring out what it is that they really need. Yeah,
most certainly. We can go in there and take a look at utilization as to how things are currently running. In the case, let's say you initially deployed our solution, Sarah, and you started out with a small cluster, right? And as a result, the overlay index was not being used, because it doesn't turn on automatically unless you change the minimum number of nodes to turn it on. And your cluster grows over time, and you realize that, oh, I need to start taking advantage of the overlay index. It's really going to help my performance for, servicing requests from the cluster. And then you think to myself, well, wait a minute, do I have enough memory in the servers that I bought and in the servers that I plan to buy to do that? And we can help you with that. We can take a look at your actual memory utilization in the system and determine whether or not you have plenty of ceiling to do that as is, or if you need to add more memory to the current systems and perhaps size the new systems to come in with a little more memory than you additionally anticipated. It's an exercise that we do all the time, and we're always happy to help people with that. I would note that a lot of this information comes to Caringo support through our health report mechanism, which is a phone home mechanism that shows us all the various statistics that are associated with the operation of your cluster. And we can actually anticipate and see, whether or not you're starting to hit some thresholds and whether you would need to consider, doing some expansion in the cluster to accommodate the current behavior that you're experiencing.
Yeah, and that proactive approach, I think, is really useful for people who maybe don't have a dedicated storage admin to be able to leverage the expertise of our engineering staff for those types of exercises.
That's exactly right, Sarah, and that's what it's there for, so that we can see it. If you enter a ticket, there's not a lot of discovery that's necessary because we already have your health report, and we can go in and get a pretty good solid look at how it's currently running, if there are any errors present, how object count and space utilization is trending over time, any kind of errors that are being returned to clients. We'll see those. We see all of that in the health report, and we can get a very comprehensive overview of what's going on. And the good news is that that health report is also available to our customers to view directly within the Swarm UI itself. We provide a link that lets you pull that up and look at that trending information. We'll talk about that more in a couple of slides.
Great.
Okay. And speaking of, here's the slide where we would talk about it. We do provide various mechanisms for capturing trends within the Swarm solution. Good old SNMP. People may not think too much about SNMP nowadays, but it's been around a long time. And over the years, we have provided Caringo-specific nibs. Plus, we also support the generic, Linux net SNMP implementation for being able to monitor and trend the operation of a cluster over time. And you can take those nibs and you can integrate that with your in-house network management system, and you can monitor things that way. We talked about the Caringo health reports already and how they provide not only a phone home mechanism for the support team, but we also cook a lot of that information and provide it in graphical format so that the customers can look at it from the Swarm UI as well. And last but not least, and this is a really important one, and if you look at the attachments and links that we offer, this also rolls back to a webinar that we've done earlier in the year regarding our Prometheus exporter support in Caringo Swarm, and how you can use that along with integrating with Grafana to be able to visualize the capacity trends and the utilization trends over time within your cluster. And in fact, we publish on grafana.com, that link you see there, we publish the dashboard that we've put together for that purpose. So anybody can go out to grafana.com and they can see the Caringo dashboard that's been published there, and they can take advantage of that and use it as well. We're big fans of the Prometheus exporter integration. It's really informative, gives you a really good insight as to what's going on within your storage cluster.
Yeah, the visuals really help your brain process the information.
It's so much easier to just be able to look at a chart and see how the line is trending, as opposed to working those numbers in your head. And the Grafana and Prometheus offering really brings that to light and makes it easy for people to figure this out. Okay. So we talked about Swarm storage in general. There are other pieces that come into a Swarm storage solution, such as the ability to do list and query based on the metadata characteristics of what's been stored in the system. And this is where elasticsearch comes into play. What happens is that in Swarm, we have a mechanism that we call a search feed. And this search feed has been designed to work with a schema that is present, that's populated into an Elasticsearch farm. And then we point that swarm search feed to the Elasticsearch farm that we want to use. And all of the metadata that's associated with the objects that are stored in Swarm ends up being, cached in the Elasticsearch farm. And we have the ability then to be able to make what we call SCSP plus API calls that, in addition to doing the generic, get, put, post, delete operations, you're also with query args be able to perform list and query of objects based on their metadata characteristics. And what we do when we size these is that we always assume that you're going to do what we call a full index of object metadata. And by that, what we mean is not only are we going to index the basic metadata that the system needs in order to keep track of everything, we're going to index all the custom metadata that you associate with an object when you store it in the system. So that lets you go back and do list and query on custom characteristics that you've associated with an object or group of objects over a period of time. And the memory required for that is the guidelines there are that you're going to need to have 64 gigabytes of RAM per Elasticsearch machine for every 1 billion distinct or logical objects that you're going to store in the cluster. And a billion, that's a lot. We have clusters out there that have way more than that, however. So, these are good guidelines to go by. As far as disk is concerned, around 1.5 terabytes is going to be required per server for each billion distinct objects for each Elasticsearch server. So, typically what we're going to recommend, we say they're a minimum of 3 to 4 for redundancy and performance for the Elasticsearch farm. Realistically, for a very large cluster, I would push that as high as 5 or greater to spread out the load for what Elasticsearch has to do when it comes to caching all this metadata information and taking the level of list and query activity that it needs to take for that given number of objects. For the networking side of that, we would recommend 1 gigabit Ethernet at minimum. Naturally, if you can get faster, that's better, but 1 gigabit minimum. And then the way you scale this out is you just scale out the Elasticsearch farm as needed by adding more Elasticsearch servers to the Elasticsearch farm. And
I always think of it like a real farm when you say Elasticsearch farm.
That's right. I feel like I'm standing here with my pitchfork down on the farm. Add to the farm.
Don't forget to wear your overalls and your work boots.
That's right. Got to put on your work boots when you're working with Elasticsearch. That much is certain. But it's pretty easy to scale out, and we don't necessarily have specific ways to monitor this that we offer as a product offering. But there's such a huge I guess the way this states, so many techniques that you can use that are for Elasticsearch that it offers that allows you to do capacity, planning and trending on your own. Just pick any one of those that's comfortable for you to use. Query Elasticsearch directly and do the capacity planning that way. There's a lot of ways to do capacity planning on Elasticsearch that make it easy.
Right.
From a Swarm Gateway side perspective, first of all, we need to describe what Swarm Gateway is. What Swarm Gateway is it provides a reverse proxy into Swarm storage, with associated authentication, authorization, accounting, and audit mechanisms for things like quota billing and policy enforcement. It's also the endpoint where we provide conversion for protocol personalities such as S3 to SCSP and so on. This is how we serve up our S3 protocol personality is by using Swarm Gateway. It's stateless, which is the good news. So the best way to treat this for capacity planning purposes is with a scale out approach. Think scaling out a web server farm behind a load balancer. That's the way you would scale a set of gateway servers. Be aware that the underlying engine is Java Jetty. So you're basically sizing Java. and that's going to drive your memory, CPU, and to a lesser extent the disk requirements. The disk requirements are basically there for local logging. Memory and CPU, and more importantly, memory is what's important here. Be aware that since it is Java, the kind of a good rule of thumb for Swarm Gateway is that if you feel like you have to size the max heap for a gateway to be pretty large, let's say like you're approaching 32 gigabytes for a single gateway, which we would never recommend doing. We would tell you to scale that out. You're going to want to stop there. And the reason for that is because of the way pointer math is done in Java. There's a lot of memory overhead and associated performance overhead going to a max heap that's larger than 31 gigabytes. So that's kind of your cutoff point for what, the amount of memory you would want to assign to a Swarm gateway. Yeah, we definitely recommend not having these large monolithic gateways. You want to have a constellation of smaller gateways that you're balancing across to address performance and scale and capacity planning. The networking that you choose should align with the choice that you used for the storage cluster. So if you roll out Swarm storage using 1 gigabit Ethernet, use 1 gigabit Ethernet for the interfaces on the gateways that are going to be communicating with the storage cluster. If you went with 10 gigabit, use 10 gigabit. Just make sure that networking speed and latency aligns with what the storage cluster is using, and you'll be in really good shape from that perspective. So let's talk a little bit about things you need to bear in mind for capacity planning with Swarm NFS. What is Swarm NFS? Swarm NFS is a protocol gateway for NFS version 4.1, and it translates those NFS version 4.1 calls into SCSP Plus on the back end. Its resource requirements are going to be primarily driven by the number of concurrent write requests that you anticipate hitting this export target. So as a best practice, it might be a good idea to split up differing NFS client workloads across multiple Swarm NFS servers. You want to scale these out as well. Your memory disk and CPU requirements are going to be somewhat higher than what they would be for Gateway. For an initial Swarm NFS deployment, we recommend a baseline of 16 gig of RAM, a multi-core x86-64 CPU, and a minimum of 40 gig of disk. And basically, that's just for the generic upkeep of the operating system that it's hosted on, as this is stateless as well. And as with Gateway, you want to make sure that your networking choice aligns with what the storage cluster is using to ensure appropriate interaction and throughput between the two components. And I just want to go back, Sarah, real quick. It's worth mentioning for Swarm Gateway as well. If you're trying to determine what is a good time to start scaling out this farm, the thing you're going to want to be monitoring here is concurrent sessions coming into the Gateway farm. Typical deployments are going to have some kind of front-end load balancer that defines which servers participate in the load balancing group. If you just want a really good top level of when you need to expand this group of servers, keep an eye on the concurrent session count and be aware of the number of concurrent sessions that each one of these gateways has been sized to tackle, and just deploy that out as a unit of additional concurrent sessions as you go through your expansion plans. Okay. And let's talk about Caringo File Fly. And what is Caringo File Fly? Caringo File Fly is a data tiering mechanism, and it's going to allow you to tier data from Windows or NetApp filers into Swarm. And this allows you to offload data from those filers into Swarm for things like long-term archive purposes, and it frees up the local disk on the filers as a result. And these type of deployments can range from simple single server configurations, in the case of Windows, to multi-server or high availability architectures. And again, it's one of those situations. It can be as simple or complex as needed, but you need to keep an eye on, how it's being utilized over time and whether or not you need to expand. The agent software itself has a small footprint. A minimal server is going to be 4 gig of RAM, an x86 64 CPU, 2 gig for disk and logs, etc. Typically, the servers that it actually runs on are going to be much larger because they are Windows filers, or they're Windows servers that are acting as F-policy agents for NetApps that data is being tiered on. They tend to be much beefier, but the actual agent software itself does not have a huge footprint. You're going to want to treat this as a scale-out solution as well. As you have more and more Windows and NetApp filers that you need to support going into Swarm, you do have the capability to run Caringo File Fly in an HA fashion. So be aware that option is there to you. You can run multiple migration agents. You can run multiple F-policy servers, and they can be set up for redundancy with Windows HA and so on. You want to make sure that these servers are close to Swarm on the network. You want to avoid as many routing hops as possible. The reason for that is that if a user were to come in to a set of data that had been migrated off of one of these filers and they want to access it again, FileFly is going to trap that request. And what it's going to do is it's going to make a call out to Swarm storage and say, pull this set of data back and make it local again, so that the user can access it and use it with whatever application they use to touch that data. So the closer it is to Swarm, the faster that operation is, and the more transparent that operation is to the end user. So that's why we make that recommendation there. And that steps right in with aligning the network interface choice again for FileFly, as you would with Gateway or Swarm NFS, to be basically the same as the network choice that was made for the storage cluster. Again, you want to have the best possible throughput and latency characteristics that you can get in this type of scenario. And as far as monitoring utilization over time and planning for expanding capacity, the standard Windows monitoring utilities definitely come into play here. You're going to be wanting to keep track of your network utilization primarily, because it is a tiering mechanism, and it's going to be pulling things or pushing things over the network as needed. So network throughput and watching for things like any kind of anomalies related to network errors, packet drops, things of that nature. You're going to want to keep track of that. You're going to want to make it, and then of course you're going to want to take a look at your memory utilization and your CPU utilization. And since it's a filer, you're probably tracking the local disk performance as well. But in the case of these tiering solutions, you really want to keep track of the networking. Make sure that that's robust and error-free, and provide you with plenty of throughput to address a potentially large number of requests to pull data back once it's been tiered out to Swarm.
Terrific.
So last but not least, we have some Swarm server reference deployments that we advertise and make available to customers as part of our overall appliance approach here at Caringo. They can range as small as being sized for SSA, or what we would call the single server appliance, where it's everything in one server. And we provide a representative protection scheme there that particular machine has been sized for. Up to dedicated Swarm servers, where you have a combination of a management server along with dedicated physical hardware for the storage, ranging anywhere from half a petabyte all the way up to 10 petabytes and beyond. So if you want to get a feel for how this scales and how we think when we're scaling this generically, for a wide range of verticals or use cases, when it comes to our appliance offering, you can get a very good feel for the thinking behind that by taking a look at these Swarm server reference deployments. And of course, if you have any questions around that, by all means, contact us here at Caringo, contact your account representative, and we'll walk you through all the thinking behind this. We'd be happy to do that.
And I think it's very valuable to have this flexibility for customers to be able to just buy our software and run that on any x86 server, or to buy it with the hardware served up as an appliance. So it's just the super simple plug it in and start using it approach.
I agree, Sarah. This is the magic to object storage being offered as a software-defined solution in our case. There's nothing preventing you, if you look at these reference architectures as an example, there would be nothing preventing a customer from mixing and matching certain combinations of hardware as the cluster grows over time. And in fact, with the features that we bring to the table that allow you to do things like volume or even full server retirement, so that you can migrate from one set of servers to another set of servers transparently while your service is still up and running, while your storage is still available to the end users, completely transparent. They never see that. It's a huge win for many of the organizations out there that use our solutions, because they don't have to schedule for extensive periods of downtime to perform that exercise. They don't have these huge service interruptions or anything like that. They could just do this on the fly and migrate from a set of small servers to a set of big servers, and the data is always available there while that operation takes place.
And it's super quick when you just go to add another server into your configuration, correct?
You're exactly right. Adding capacity for swarm storage is incredibly easy. It can be done on the fly. No downtime is involved. What you do is you just make sure that the server that you're going to be adding to the cluster is plumbed to the storage network, where all the other current storage servers are. And what happens is you boot that up, and then our platform server sees that boot up request, basically in the form of a PXE boot request. And what we do then is we serve up the swarm runtime image that runs in main memory. There's no operating system install here at all. And it boots up in main memory. It goes out and sees what disks it recognizes on the server. It formats them for use by Swarm, shows them as mounted, indicates that the node process is ready to take requests. And at that point, that server has joined the cluster and can take client requests, for adding new data, for intra-cluster bookkeeping to move data around to new storage that's available, for balancing, and so on. There's very little, if any, intervention required from the operator's perspective to bring new storage up and add capacity. It's simple plug and play.
And what does it take? Under 2 minutes?
Yeah, typically it's going to take as long, in my observation, it takes as long as it takes for it to PXE boot and boot up our runtime image and then see the volumes. It's very fast.
Because I've heard 90 seconds.
I would say 90 seconds is fair. Most servers these days can boot up, PXE boot, and start running in about 90 seconds.
That's some almost immediate gratification.
Well, and the key thing here is that it's not manual. It's auto discovery. You're not going in and adding, to a list of servers that are participating in the cluster and have to manually add another thing that you've had to, think about what IP address am I going to give this, blah, 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 blah. You just boot it up and it runs. And voila, you have expanded storage. Nice and easy.
Nice. Well, and it's so valuable for businesses that know they're going to be growing to know that they can do this very easily.
I think the term we use is pay as you grow, right? You may anticipate needing 20 petabytes 5 years from now, but there's nothing forcing you to purchase that 20 petabytes up front. You can start out with half a petabyte. And then as you fill that up, you add more servers. Now we're at a petabyte. And then later on, you plug in a few more servers. Now we're 2. Eventually you're at 10, 20, 50, you name it. And it's all done on the fly. A
whole farm of servers.
That's right. With our pitchfork and our work boots.
We should recreate that painting someday.
I think we need to put that in as a graphic.
Absolutely.
Okay.
We'll work on that
very good.
For a further webinar. Can you believe, John, that we've been doing the Tech Tuesday webinars for almost 2 years now?
It's been quite the run. Yeah, and I just want to point that out to our folks out in the audience. There's a large pool of these webinars and information that's available to you out there, for you to review at your pleasure. And we certainly recommend that you go back and take the opportunity to go through some of those webinars. There's a lot of good information there from people that have participated in them, that are from our engineering team, from our sales team, marketing team, our executives, you name it, to give you a lot of insights into Caringo, our solutions, and how they can help you with the storage problem that you're facing.
I think one of the hallmarks of this series has really been having the technical talent on it driving. If you go back and look, you'll notice sometimes we have John in the host seat, sometimes we put them in the subject matter expert seat, but we always have somebody with a very high level of technical knowledge on these webinars. And I think that is so valuable, and I learn something every single time.
And to that end,
I will be. Tell us what you have on tap for December 10th.
Sure. December 10th will be our next Tech Tuesday webinar, and in that one, I get to be the MC as opposed to the subject matter expert. And we're going to be talking about evaluating object storage solutions for 2020. And the subject matter experts we're going to have available are Juan Gonzalez and Ryan Meek. They are from our sales engineering team, and they're going to walk you through, how you would evaluate all the different object storage solutions that are available to you in the current marketplace.
And that's going to be a great session. I'm really looking forward to listening in on that one. So
they've put a lot of work in that, and I would definitely recommend that if people have the chance to attend, that they do so. There's going to be a lot of good information in that presentation.
Well, and it'll just be fun. So I think that there'll be a lot of going back and forth between the three of you. I suspect you will insert your opinion as needed. So I want to thank you all again for attending our webinar today, and we encourage you to follow our blog. Our LinkedIn, Twitter, and Facebook accounts are all available to follow, and you can always email us at info@caringo.com. and we will get back to you. We love to help our clients. We love to help people who are currently evaluating storage systems understand better the value of object storage technology.
Thanks very much, Sarah, and thanks to everyone in our audience. We hope you all have a great day.
Thank you so much, John.
Bye-bye.
Bye.